All right. So today we are going to be doing 411, which is quadratic formula and discriminant. In 1637, René Descartes published law geometry that contained a variation of quadratic formula that we use today. Since then, many studies have committed the formula to memory, as it is one of several methods used to solve quadratic equation. But how was this formula developed, basically? It was actually developed by completing the square. So we just finished up our sections on completing the square. So now we're going to apply it conceptually. So this is what we call standard form of a quadratic. Everybody recognize and remember that format? Now we can use standard form to manipulate the variables, okay? A, B, and C just represent numbers that we don't know, okay? And x being the main variable. And we can manipulate it in a way that allows you to derive the quadratic formula. Now, I'm going to go through these steps of deriving the formula. This is a little bit high level, so I don't expect you to be able to reproduce it. Just try to follow along the steps so you kind of get a general understanding of this, okay? So like I said, the stuff you actually have to do is going to be the next set of things. So the first thing we're going to do is we're going to isolate the c. So we're following all the same steps that we follow when we complete the square. So I get the c to the right side. The next step is to divide everything by a. So if I divide the first term by a, it's just x squared. B divided by a is just b over a. And negative c divided by a is just negative c over a. So now we are going to take half of this term and square it, because remember, you always take half of this and square it to complete the square. So why is it, do you guys feel like it's really warm in this room?
Yeah.
Well, nobody else is going to do it, even if I wanted to. So basically, if I want to take half of this, I would multiply it by 1/2, which gives me b over 2a, right? And that's half of that. But we don't just take half of it, we take half of it and then we do what to it? Square it, right? So we do half of this term squared. And what I add to one side, I have to add to the
other side.
Good. So that's going to be b over 2a squared minus ca over a as well. So when we go to complete the square, we always factor this into two identical binomials, right? And it's always whatever half of this term is, which we determine is b over 2a. And that's equal to, what is b squared? Just b to the
second power.
And what is 2a squared?
2a to the second power.
Which is 4a squared.
Love it.
Alright, is everyone good with that step there? Like I said, this is just a conceptual understanding. I know you're not really used to working with variables in this way, so it is a little bit, it's a lot to take in.
Actually gonna have to do this?
No.
Okay.
This is just so you understand where the formula comes from. So how can I rewrite this if it's the same thing written twice?
Square it.
Good. And then here, if I want to combine these, I have to have a common. Good. So I can multiply the top and bottom of this by 4a, which will give me one big denominator of 4a squared. So it's just going to be b squared minus 4ac. And this was squared, as we said. And then the last step of completing the square is to take the square root of both sides. Over here I get x plus b over 2a. And over here I get plus or minus the square root of the numerator over 2a, which is the square root of 4a squared. And then the last step is to get x by itself, which means I'm going to subtract this over on both sides, which gives me x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Which if you then combine into one denominator, is the quadratic formula. So like I said, I know that the steps are confusing. If you didn't understand every step, that's okay. But the main idea, the main idea is for you to understand that from here to here, we were able to rearrange the equation in such a way that we come up with the quadratic formula. Okay, so that's how it was developed. Like I said, this is a bit higher level math than you will all need to understand, but just something important to think about. Okay. Mm-hmm. Are we good to move on? Okay. So the quadratic formula not only generates solutions to quadratic equations, but also tells us about the nature of the solutions. When we consider this discriminant, so the discriminant is just the portion of the quadratic formula underneath the square root. It tells us whether the solutions are real numbers or complex numbers and how many solutions we have. So there's a few different things that can happen here. We can have what's called two imaginary roots. And two imaginary roots can happen two ways. Your graph can either be positive and above the x-axis or negative and below the x-axis. But in either case, will it ever touch the x-axis at all? No, and that's the goal of an imaginary root. It never touches the x-axis. So that's an important thing you need to know about an imaginary root. Never touches the x-axis, okay? Now, one real rational root can happen two ways as well. You can touch the x-axis once and then go upward, or you can touch the x-axis once and be going downward. So the next type of root we can have are real rational roots, two of them. That means that our graph crosses the x-axis twice, and it can do that either by going upward or downward. And two rational real roots means that it crosses the x-axis at something like -4 and -1.5, any type of rational number, okay? And the next type is going to be two real irrational roots. You're still going to touch the x-axis twice, but when you touch the x-axis, it's going to be at random values that are not nice numbers, like square root of 2, or square root of, I don't know, 1.5. I'm just giving you some random examples there. So when you take a square root of a number and in your calculator it gives you like a decimal that is not repeating, that means that that's an irrational number. And with irrational roots, we often leave them in the form of radicals so that they are complete. So now we're going to go ahead and complete using the square root or the quadratic formula. So the first thing you need to do is ensure that your quadratic is in standard form. Is this quadratic in the form ax squared plus bx plus c is equal to 0? Yes. So since it is in that form, we are ready to proceed. What is the a value here?
2.
Good. What's the b?
25.
And the c?
33.
Good. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4AC all over 2A. Now in that formula, I'm going to be plugging in for A, I'm plugging in for B, and I'm plugging in for C. So that's giving me X equals. Now keep in mind, when the formula has a negative variable, it's going to change the sign of what you plug in, which is going to be negative 25 plus or minus the square root of B squared minus 4AC all over 2 times A, which is 2. So do you remember using this formula back in algebra days?
Yeah. That was actually not that long ago.
No, not too long ago. Been a little while, but. All right. So does everybody understand how we went from here to here? So, do you understand this formula?
Yeah, it's on the front page, right? You just have to plug it in.
Plug it in. The only thing that is remotely that you have to know about it is the B thing. So since it's a negative B, it's always going to change the sign of the B when you plug it into that first value. So the next step is just going to be to simplify. So we have negative 25 plus or minus the square root of 25 squared is 625 minus 264. So that's just me doing this multiplication right here. Came out to be this. Okay. All over what?
4.
Good. So the hardest part about this is having enough room. So this will actually simplify to give me, and I'm going to write it up here because I'm kind of out of room, x equals negative 25 plus or minus the square root of 361 all over 4. So the good news is the square root of 361 is actually a perfect square. So if you do it in a calculator, it actually comes out to be 19. So sometimes it will be a perfect square, and that's good news. It comes out nicely. So that means we have two solutions. We have x equals negative 25 plus 19 over 4, and we have x equals negative 25 minus 19 over 4. Now if you simplify each of these, this one up here is going to give me negative 6 over 4, which is equal to negative 1.5. And this one down here gives me negative 44 over 4, which comes out to be negative 11. You see it? So how many solutions do I have?
2.
Good. And are they real?
Yeah.
Yes. And they are rational. Real and rational. So you can see that the solutions are real and rational by looking at the solutions, but you can also use the discriminant to determine this. So let me talk a little bit about that. The discriminant is just the portion of the formula underneath the square root. If what is underneath your square root is a positive number, you know you're going to have 2 real roots. Okay? If what's underneath your square root is 0, you know you're going to have 1 real root. And if it's a negative number, you know you're going to have 2 imaginary roots. So you actually kind of know before you actually know, if that makes sense. So my 2 solutions are negative 11 and negative 1.5. So what do you think? Does it make sense?
Yeah.
Are you ready to try another one?
I don't want to, but I guess.
Okay. Good enough. So what is the A value here?
1.
Good. The B?
Negative 16.
Good. And the C?
64.
Yep. So the formula x equals negative b. So if it's negative b, my b is going to become
Positive 16.
good. Plus or minus the square root of b squared, original b squared, only the one on the outside is negative, minus 4ac all over 2 times a. So this is really important. On the homework, you're not going to have any credit unless you show me this step. Okay, you need to plug everything in because I know there are ways to get the answer to this without doing any work, and I need to see that you're plugging into the formula. So if you don't have this step, you're not going to get credit for your homework assignment. Okay, if you just go down to the bottom and give me 2 solutions, which will probably, if you're not doing the math and you're just using some kind of software, it's going to give you your answers in a really weird way that I will notice because they do the math very differently. They use completing the square method. So just be aware of that. Oh, I'll take your test. So now we're going to go ahead and continue. That's 256, because I square a negative number, it becomes positive, minus 256, all over 2, 1 times 2. What is 256 minus 256?
0.
Good. So we end up with 16 plus or minus square root of 0 is equal to 2. And what is the square root of 0? 0. So I have 2 solutions. X equals 16 plus 0 over 2, and x equals 16 minus 0 over 2. Both of these come out to be what number?
X equals 8.
8. Does everyone see why they both come out to be 8 here? Okay. So how many solutions do we have here?
1.
Good. And is it real?
Yeah.
And is it rational?
Yeah.
How do
So
you tell if it's rational or irrational?
the only time you're going to have an irrational solution is if you have a square root that cannot be simplified all the way down, so you still have a square root left. Okay? Any other questions about this one? All right. We'll do 2 more examples and then you'll have time for homework. So A is 3, B is 5, C is 1. Formula x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's x equals negative 5 plus or minus the square root of 25 minus 12 all over 6. That's x equals negative 5 plus or minus radical 13 over 6. Yes. So, is there anything I can do with the square root of 13?
No.
No, it breaks down into 13 and 1, not very helpful. So, this radical doesn't simplify at all, and it's still going to be a radical in the end. So, these are our 2 answers. X equals negative 5 minus radical 13 over 6, and x equals negative 5 plus radical 13 over 6. Remember, this is an important step I'm looking for on the homework, so make sure you put it on your homework. How many solutions do we have?
2.
Are they real?
Real irrational.
Real and irrational. Irrational people are still real people, okay? You can't forget about them just because they're irrational. So we have negative 5 minus radical 13 over 6, and negative 5 plus radical 13 over 6 as my two solutions. So these are my solutions right here. Do we have any questions about that? Does anyone need more time? All right. Looking at number 4, am I in the form ax squared plus bx plus c equals 0? No. Bathroom? Yeah. So what do I need to do to the c?
Add.
Good, I have to add it to the other side. Now am I in the right form?
Good.
So a is 1, b is negative 4. That was a terrible 4. And c is 13. So that's x equals negative b, which becomes a positive 4, plus or minus the square root of b squared minus 4ac all over 2a. That's x equals 4 plus or minus the square root of 16 minus 52 all over 2. So I'm just doing that math, you know, I already knew the answer, so I'm just doing those calculations. That gives me x equals 4 plus or minus the square root of negative 36 over 2. So what is the square root of negative 36? 6.
6 square root of 6.
What happens when you take the square root of a negative?
Imaginary, 6 up.
Good. So this is almost your final answer, but not quite. Because I can rewrite this as 4 over 2 plus or minus 6i over 2, right? Just divide each term separately by the 2. What is 4 divided by 2?
2.
What's 6i divided by 2?
3i.
Yep. When she comes back. How many solutions do I have?
2.
What kind of are they?
Imaginary.
Good. Now here's something important to note about imaginary solutions. Do you remember how we talked about conjugates the other day? Conjugate is where you change the sign between the complex numbers. See how these are conjugates of each other? That will always be the answer to your solutions when you have an imaginary. They will always be conjugates. So that's just something to look for. Now, before you start your homework, I assume you'd like some hints on some problems, or at least to get you started. Because there are a few that have simplifiable radicals that I want to kind of address. So I'm not going to give you, it's not on a specific problem, but the square root of 44 comes up, okay, maybe once or twice. So say you have something like this, 2 plus or minus the square root of 44 over 2. Okay, that's what you get, x equals. Now, here's how you would simplify this. That becomes radical 4 times radical 11, right? What is the square root of 4?
2.
So that's 2 radical 11. So 2 plus or minus 2 radical 11 over 2. And then that would become 2 over 2 plus or minus 2 radical 11 over 2, right? Which becomes 1 plus or minus radical 11. So see how this becomes this if you simplify properly. So just make sure you're fully simplifying your radicals and whatnot. Just be careful of that. So that's all I have for you today. You have a solid 20 minutes.